All right, hi everybody. Welcome to the Dilutions Lecture video. This video is going to be a very short lecture and a lot of practice problems. All right, so for dilution, one of the things that we want to make sure we understand is exactly what they are. So just kind of think of any solution that has a solute and a solvent, and then think about what would happen if we took some of that solution and we changed its volume. What would happen is a resulting molarity change. Now, whether we added more solvent or we took some solvent out, doesn't matter. Our solvent and solute are going to still be in that solution. Now, in order to calculate this, we need an equation. And the equation we're going to use is M1V1 equals M2V2. What these variables are going to represent is anytime you see an M, a molarity in moles per liter, and a V is going to represent a volume in liters. These are our units. They must be these units. Please don't forget that when we've talked about units in the past, that if you have to convert, you convert before you do the math. The 1 and the 2 stand for initial and final values. So M1V1 means anything initial. M2V2 means anything final. All right, our first practice problem is going to have our M1V1 equals M2V2 equation. Okay, so we're just going to write that up in the top so that we have it for later. From there, our first step is always going to be to define the variables. Okay, so I'm going to write out what my variables are in my equation. And then I'm going to try and identify them in the actual problem. So this says, what is the final molarity? So already I know M2 is going to be my X. It also then says the final volume down here is going to be 1 liter. Those look like they're going to have the right units so far. Next thing that we're given is that we were told a solution of 0.5 liters that has a concentration of 4.3 molar. So there we go. We've got them all. Step 2 is going to be to plug and chug. So I'm going to plug in my initial molarity times my initial volume. Again, if these are in the right units, we don't have to do anything to them before we actually do our math. So in doing this math, I'm going to grab my calculator real quick. I get a X value of 2.15. That value was a molarity, so its unit should be molar. And that's our first problem. All right, moving on to the next one. All right, so again, I'm going to remind you of our problem. Our equation. We're going to go through and we're going to define our variables first. I know in the formula that these are the 4 that we're going to need. It says, what is the volume of a solution needed? So that means our V2 is going to be our X. If a volume of a molar solution, so 0.25 liters and 5.3 molar, is diluted to a concentration of 2 molar. Okay, so then I'm going to do my second step, which is to plug and chug. Now, I knew these were my initial values because they were right next to each other. So that's just one way. And then if you say that this solution is diluted, there's a good phrase to look for. Is diluted means that it's going to change volume. So, or change its composition. That means whatever comes after that is going to be our final information, just kind of real quick. Next thing we're going to do is we're going to do the math on that. Apologize for the noises. My husband's upstairs in the kitchen directly above me. 2 and X. This gets you an X value of 0.6625. I know that this is going to be a volume in liters, and so when I go to report my final answer, I'm going to round it to 3 decimals, 3 sig figs, if you will, before I say I'm all good. All right, that was my second one. My next one is going to be, again, we're going to start by defining the variables. Okay. Our solution is made by adding 50 grams to 400 milliliters of solvent. This looks like information about an initial molarity. So what I'm going to do is I'm going to try to figure out what this stuff means. I'm given a mass and I'm given a volume. In order to get molarity, I know that I'm going to need moles and I'm going to need volume. And this is all from this section. And when I say I need moles, we know the unit on that one. We know the volume is going to have to be in liters. Okay. All right. So in order to get moles of CCl4, I need to know the molar mass of CCl4. If I want to go from grams to moles, then I know I'm going to need the molar mass in between. All right, so how do we get the molar mass of a compound? Remember, in our case, we're actually going to do the periodic table method. So I'm going to take Cl, which is 35.453. And then I'm going to add 4. Oops. Sorry. I'm going to do 4 of these. When I do that math, sorry, 141.812. I'm going to add the mass of 1 carbon. I'm going to get a molar mass of 153.823 grams. And this is all the number of grams in 1 mole. All right, I'm going to erase some of this because hopefully this is all review. And I'm going to leave this down here for now. All right, so we're still trying to work on our molarity calculation. So the next thing I'm going to do is I'm going to start with my 50 grams of the CCl4. I need to get to moles. So I'm going to divide by the molar mass. And that's going to leave us with 0.325 moles of CCl4. And this is, of course, going to be all M1. So far, we know it's going to be moles over volume in liters. So far, we know the number of moles. We just calculated that. Oops. Hopefully you feel pretty good about calculating these concentrations after that last homework set. We're going to divide by the volume. In this case, our volume is 400 milliliters. 400 milliliters is going to actually be 0.400 liters. Divide by 1,000 to get it. This calculation says that our concentration of our initial solution is 0.813 molar. All right. I'm going to erase my calculations on the molarity, as now we have that. So we had to do some initial investigating to figure out what that first molarity was. The next thing says, if 200 milliliters of this solution, so this is the volume that we're actually going to take of that initial molarity, we're going to convert it to liters by dividing by 1,000. It says if this 200 milliliters of this concentrated solution is then diluted, so now we're talking about final stuff, to a final volume of 600 milliliters. So I'm going to put that in down here. The next question says, what is the final concentration? So that's M2. So again, we're going to do some plug and chug. And that gives you that final molarity. So this puts together a lot of our previous stuff in that in trying to calculate a molarity, we have to go from grams to moles and then divide by a volume. This is going to be an interesting approach to these different problems, but this is more like what you would actually be seeing because this is the kind of thing that I would make you do on a bench. All right, that brings us to your problems. Sorry, I'm not going to do the fourth one. But you are welcome to do it if you want on your own. Your problems are these three. I'd like you to take your time, do them, and once you are done with them, you're going to email them to me, and I will respond with the answer key. Okay? Thank you very much.